Okay, now we are going to go to the next example. Example 9.43. Alright, so in this example, we need to find the dimension of the cuboidal box. Find dimension of cuboidal box. Okay, without a top, of maximum capacity whose surface area is 12 meters square. Okay, so we want to find the maximum capacity. So without a top, no top. Okay, this has some condition there. We want to find max capacity. So max capacity is the volume, and also another condition is surface area is equal to 12 meters square. Alright, so it is a realistic problem, a practical problem. So we can use the method that we learned just now for this problem. Okay, so but we need to understand what is the main function and what is the constraint. So for the main function, for the capacity or volume of the cuboidal box is, so we put it f x y z. So x y z is the side of the cuboidal box. So this one is simple. F is the function of the volume. So the function is x, y, z. Simple. So I will draw the box. So okay. Now because there is no top, so this one is hollow. This surface is hollow. So the surface the surface that is available is only 5, which is 1, 2, 3, 4, and the bottom one 5. Okay, remember that. So now x is, let's say this is x, and this is y, and this is z. Alright, so remember we have constraint, which is the surface area is 12 meters square. So we can make the constraint equation. So g x, y, z. So the constraint is the surface area. So we need to calculate all surface in the cuboidal box. So but remember that we don't have the top surface, so we need to exclude that. So for surface xy, we only have one, so plus xz. So xz, actually we have 2, so we need to write 2 xz plus 2 zy or yz. Alright, so this is the constraint, not finished yet, so we need to make it equal to 12. Okay. Okay, so now since we know the function already, but since we want to use the letter method, which is the one that include the auxiliary function, so we need to make the g function, the constraint, is equal to 0. So xy plus 2xz plus 2yz minus 12 is equal to 0. Alright, and then so this is the function that we will include in the auxiliary function. So remember, the auxiliary function x, y, z is equal to first the function, the main function, x, y, z minus lambda. So we put the constraint, this one, okay. So x, y plus 2xz plus 2yz minus 12. Alright, so and now we want to consider the partial derivative as well, because we want to find the stationary point. Okay, remember, when we consider a practical problem like this, we need to know that what is the minimum point. Okay, the minimum point is, of course, it is 0, because when x is equal to 0, x is equal to 0, y is equal to 0, z is equal to 0, so the cuboidal box is vanished, has 0 volume. So that is the minimum point, right? Okay, so with the constraint given here, so we can find the maximum value, maximum capacity with the given surface area. Okay, so first we use the partial derivative to find the stationary point. So delta psi delta x equal to yz plus lambda y plus 2z, and this is equal to 0 because we want to find the stationary point. Delta psi delta y equal to xz plus lambda x plus 2z equal to 0, and the last one, delta psi delta z equal to xy plus lambda z. Is it correct? Nope. This one is little different because remember we have one surface removed. Okay. Alright. So we have these three partial derivative. Okay, now in order to solve this, we can use a very lengthy method, which is we find one by one, because we have three independent variable right here. So or we can use a creative method, but this is not applicable in all problem. So this creative method is proposed in the book, so if not, we need to use the lengthy method. So what is the proposed way is taking x time, let's say before that I denote this by A, and this one is B, and this one is C. Okay, so x time, we time with the derivative of the respected variable. So A plus y time B, and plus z time C. So this is a method that you need to discover by yourself. what is the purpose of this method is, this is not applicable for all problem for this subtopic. This method is to find to obtain an equation that has form like this, that has this kind of form, which is the constraint. Okay, why? I will show you why. So we continue. So the outcome will be, so I simplify it. I just go straight to the answer. So this is the answer, lambda and 2xy plus 4xz plus 4yz. So this is the answer, and this is equal to 0. Why? Because this one is equal to 0. Why? Because everything here is equal to 0. So when we put A, B, C inside here, A is equal to 0, B is 0, C is 0. So everything is equal to 0. Okay? So now we can simplify again. Okay, now we can see that this component has a form like this equation, the constraint, but the value is a little different, so that's why we need to simplify it. So we will have lambda xy plus 2xz plus 2yz, right? And then plus 3 over 2xyz equal to 0. Alright. So right now then we can substitute, replace this with the value in the constraint. So in the constraint, we have the value is equal to 12. Therefore, we can simplify it. 12 lambda plus 3 over 2xyz. Right. So this is a very genius way to solve this. So we can simplify everything into this short equation. This one. So from here we can find lambda. So lambda is equal to negative 1 over 8 x y x. Okay. Is it correct? I think we have problem with the with the book a little. I think it's not x y x, but I think it's x y z. So that's why I also confused. So it is, I think, yes, it is x y z. Yes. Okay, now we can put this value inside equation A, B, C right here. So we can know the value of yes, we want to find the value of y, z, and so on. Okay. So when we put the value inside the A, B, C, so it will be 1 minus 1 over 8x y plus 2z. So this is from A equation. And for B, 1 minus 1 over 8 y x plus 2z equal to 0, and the last one z 2x plus 2y, okay, equal to 0. Alright. So let's say this is D, E, F. Okay. So when we subtract E minus D, okay, what will happen is we can get that 1/4 YZ minus 1/4 X Z equal to 0. Okay, so Y is equal to X. So this is the value of Y and X, but we don't know the value, but we know that Y is equal to X. Okay, and putting this into the f function, so the outcome is 1 minus 1/8 Z okay 2x plus 2x to 0, and then you can get that YZ is equal to 2. Alright, and then we substitute again this one into equation D. So it's quite lengthy, and you need to arrange it so that you can solve all the variables. So when we put it inside the equation D, what will happen is 1 minus 1/8 y square minus 1/2 equal to 0. Now we can calculate y. So y square equal to 4. So y is equal to, it can be plus minus 2, but since we consider a realistic problem, there is no negative dimension for the cuboidal box, so there's only 2. The value of y is 2. Okay, and then of course x is equal to 2 also, and then we can find z is equal to 1. Alright, so this is the value of the xyz for, in order to get the maximum volume of the cuboidal box with the constraint of 12 meter square surface area. Okay, so since I said it again, because the minimum value for the function f function is 0, because when y is equal to 0, x is equal to 0, and z is equal to 0, where the cuboidal box is vanished, that is the minimum point. That is the minimum volume of the cuboidal box. Therefore, this 3 value is the value that we can use to find to get the maximum volume of the cuboidal box which is constrained with the 12 meter square surface area. Alright, so I think that's all for the example 9.43. Hopefully you understand, and you can apply this in other problem or example. Okay, thank you very much for your time. Hopefully you understand. See you in the next lecture. Assalamualaikum and have a good day. Bye bye.